Moving right along then, solution number 6, again, don't worry, we are running through these as an introduction. We'll come back to details of each one. Solution 6 is narrowly target direct regulatory measures such as rebates and efficiency and renewable energy portfolio standards at high emission sectors not covered by market-based policies. Okay, so this is a figure from the UN Statistics Division showing fossil fuel subsidies in 2015. We already looked at the cost of fast transformations needed to go to low carbon economy. This is showing that basically across the world, fossil fuel pre-tax subsidies measured in current US dollars in 2019 is that every country has some sort of a fossil fuel subsidy. Why is it important? Because most of these countries are not producers of fossil fuels other than coal maybe. So even when a country like let's say India imports gasoline, and if it gives a subsidy, then obviously it's spending its well-earned income on subsidizing pollution, right? So the real cost of fossil fuel in any country is not always easy to find. If you go to the Middle East and they have huge subsidies, obviously it's understandable because they are just sucking it out of the ground, and Russia produces some, US produces some South American countries produce, Venezuela, Brazil and so on. Market forces affect these things as well. When oil prices drop, economy of something like Brazil almost entirely collapsed, right? So solutions have to keep that in mind, especially in terms of regulatory measures to push things in the right direction via the market forces. Okay, technology measures cluster. There are 3 solutions in this cluster that focus on both carbon dioxide and SLCPs. These represent the first 2 levers discussed before, carbon lever and the SLCP lever. So number 7 and 8 represent 2 stages of pulling the carbon lever. Solution number 7 pulls the carbon lever nearly halfway by 2030. Remember the relay race, the SLCP has to have started already, and carbon lever has to take off at full speed by 2040, but it would have to have started a preparatory run by 2030 itself. Solution 8 pulls it the rest of the way by 2050. So by 2050 it has to be in full speed. Solution number 9 representing the SLCP lever by 2030. Okay, so here is solution number 7. Promote immediate widespread use of mature technologies such as photovoltaics, wind turbines, battery and hydrogen fuel cells, electric light-duty vehicles, and more efficient end-use devices, especially in lighting, air conditioning appliances, and industrial processes. So these big trucks, when we say light-duty vehicles, we mean going from diesel guzzling big transportation trucks, which are a very important part of the economy, to fuel cells and other technologies, and more efficient end devices. So there are many star rated appliances now, like refrigerators, washers, dryers, dishwashing machines, vacuum cleaners and so on, which actually have high efficiency promises. Lighting, there are more and more bulbs being offered. Obviously we have to get away from incandescent bulbs, which mostly waste energy as heat, to LEDs and CFLs and so on. Okay, here is the share of primary energy supply. You can see petroleum, coal is still a massive part of the financial year 2018 energy portfolio. Nuclear is a little bit, renewable is here, natural gas. So coal and petroleum, high emission fossil fuels, are still more than 50%, almost more than 60% of the contribution. The key question is, how fast are renewables growing? So forget the technologies for electric vehicles and so on, just the energy source needed. Where is it coming from? So if you look at the contributions here, you can see that over time, nuclear from 2000 to 2018, nuclear is kind of almost disappeared. Renewables have increased but still remain a tiny fraction of the portfolio. Not a huge fraction at all. Natural gas is lower emission than coal, obviously, and gasoline. US found a huge source of natural gas and its emissions dropped. Not emissions dropped, but consumption didn't drop. So just because you switched from a high emitting source to a lower emission source, you dropped the emissions. But US also increased coal exports during that time. So you're just emitting elsewhere. India is a huge importer of coal, for example. Australia is a huge exporter of coal. Australia is known as a coal-loving country. Okay, so complicated issues. You cannot just wish them away. Hardest emissions to eliminate: global fossil fuel and industry emissions. These are the kind of emissions that are mentioned in the solution. Base load electricity, short distance load, light load transport, cement production, iron and steel production, they remain significant contributors. Variable electricity, so these are the difficult to eliminate emissions here. Aviation, long distance road transport, shipping. And then there are these that are accessible to reductions: residential and commercial use, heat, combined heat and electricity, and so on. So the electric vehicle sales in the world from battery or combined plug-in hybrid vehicles, you can see the numbers from 2010 to 2019. China is a monster. It's selling a lot of electric vehicles, battery vehicles. The market share has grown, but it's still tiny percent. It's still around 2.5 to 3%. Okay, these are in thousands, so you are reaching a couple of millions, but a tiny fraction of the total sales. Okay, how does the outlook appear for annual global passenger car and light duty vehicles to 2030? You can start in 2010, and you can see here projections are not bad in terms of global market share, getting up into the mid-20s and beyond, but still not a majority of the share. So here is global passenger car and light duty vehicles in millions. The vehicles in terms of internal combustion engines versus battery or plug-in hybrids, the share is projected to increase, and obviously along with that the ICE will drop, but not as impressive as you would want to meet the emission targets. So this is why many reports